Good morning. In our previous discussion, we have discussed construction and working of bomb calorimeter. So today, let us discuss what is knocking and its mechanism. Before that, let us discuss the working of engine also. So what do you mean by knocking? Knocking means knocking. In general means knocking of a door, right? Whatever it is. The same thing happens in case of IC engines also. That is internal combustion engine. It might be diesel engine or petrol engine. So the mechanism of knocking in gasoline, that is petrol engine, is different with that of diesel engine. So before discussing what is knocking, the mechanism of knocking, let us see how our IC engines work. Okay, so IC engines. So IC engine will have two strokes. Will work in four strokes. Your internal combustion engine, whichever engine we have, it works with four stroke. Let us assume this as our IC engine. Okay, so it will have a internal valve and also an external valve like this. So the first stroke, the first step or first stroke, whatever we call it, as inlet. So the inlet valve will be open, whereas the outlet valve will be closed. Okay, so through the inlet valve, the fuel air mixture will be sucked in. Second stroke is compression stroke, wherein the fuel air mixture will be compressed. Okay, fuel air mixture will be compressed. So piston moves downward. Third stroke is the ignition stroke. The fuel air mixture undergoes ignition. A spark will be produced. The fuel air mixture undergoes ignition, and what produces? It produces carbon dioxide, water, and energy. So energy will be used, the mechanical energy. It will be whatever energy is produced, it will be used for running the vehicle or anything, any other purpose, right? So the fourth stroke, the exhaust. This is the exhaust will open. The carbon dioxide, water, other gases will come out. So this is called as smooth combustion. If this is a cycle, first stroke, inlet of fuel air mixture, second stroke, compression, third stroke, ignition, fourth stroke, exhaust gases will go out. This is called as smooth combustion. If this occurs step by step, no knocking will occur. Then why knocking occurs? I'll tell you. So once again, let's start from the first stroke. The first stroke, what happens? This is the inlet valve will be open, fuel air mixture will be sucked in, the exhaust is closed. Second stroke, the fuel air mixture will be compressed. When the fuel air mixture is compressed, what happens? Temperature increases. So how it compresses, you know that when pressure increases, when pressure is applied, temperature also will increase. So because of that temperature, part of fuel will undergo combustion. So it undergoes combustion, it liberates various gases. So these gases tries to escape outside the engine. So but the outlet is closed. Since the outlet is closed, it cannot go out. These gases hit the inner walls of engine and piston with high pressure, producing a rattling noise, and that noise is called as knocking. So what are those gases produced? When they are produced, we'll see. So until the fourth stroke, the exhaust will not open, right? So second stroke only these gases are produced. So in third stroke, until the fourth stroke, the gases will hit the internal walls of engine and piston with high pressure, producing such type of noise. And this noise, which is very irritating, is called as knocking. So what are those gases? What is the reason for that? We'll discuss in our next time. So before that, I have a small video for you. Just go through this video, which shows the functioning of engine and also smooth combustion and explosive combustion. This is normal combustion, as I told you. Suction stroke, compression stroke, ignition stroke, and finally exhaust. This is regular combustion. This is knocking. See, during compression itself, fuel it undergoes ignition. So see that? That is the problem. This is why knocking occurs. So fuel air mixture inlet, compression. So during compression only fuel undergoes ignition. The combustion pressure. So knocking is caused due to this pre-ignition. What is pre-ignition is very clearly given over here. There is nothing but before the section third stroke only ignition occurs in the second stroke. So this part pre-ignition. So when the fuel is compressed itself, ignition occurs. Before spark is produced, the fuel will compress. So come once again. These are the two reasons for knocking. If you change the torque, also you can minimize knocking. This is regarding friction. Okay, so this is how knocking occurs. So let us see why this knocking occurs. Okay, this is, I already have told you, I've explained you the compression, I've explained you what is knocking. What is, how your engine functions, right? And I've showed you visually also. So let us see what are the gases produced. So that part was not there in your syllabus. This part is there in your syllabus. Okay, so there is something called as compression ratio. So what is compression ratio? It is volume of engine before and after compression of fuel air mixture. That is the volume of engine before and after compression of fuel air mixture is called as compression ratio. So as the compression ratio increases, your efficiency of the engine also will increase. So beyond certain compression ratio, explosive combustion of fuel air mixture occurs. So because of this, it produces some thermal shock waves. So these waves hit the inner walls of engine and piston, producing a rattling noise known as knocking. Right. So knocking hence is defined as production of rattling sound as a result of explosive combustion of fuel air mixture due to increasing compression ratio. Okay, so what is compression ratio? It is the volume of engine before and after compression of fuel air mixture. Okay, as compression ratio increases, efficiency increases. So beyond certain limit, what will happen? It produces some thermal waves which hits the inner walls of engine and piston, which causes a rattling noise, and that is called as knocking. So let us see the mechanism involved in knocking. So the mechanism, it is nothing but, so here the mechanism. So here this is normal combustion. So you have, let us consider ethane as a fuel. Okay, you cannot consider pentane or heptane. So if it's ethane as a fuel, it combines with oxygen to give you carbon dioxide and water. That is in normal stroke, first stroke, second stroke, compression, third stroke is here. Third stroke is nothing but third stroke is spark and ignition, fourth stroke is exhaust. Okay, that undergoes part by part. then this is normal combustion. So if this occurs, there is no knocking. So something is called as explosive combustion. What is explosive combustion? First stroke is suction stroke, second stroke is compression. So during compression itself, part of fuel undergoes combustion. So when it undergoes combustion, it produces the intermediate compound. What is that intermediate compound? Dimethyl peroxide. So this dimethyl peroxide is a gas. It cannot escape into the atmosphere. It cannot go out of the engine. Exhaust is closed until the fourth stroke. This is produced in the second stroke. This will further decompose to give you acetaldehyde. Acetaldehyde will further undergo oxidation to give you formaldehyde. Formaldehyde will further decompose to give you, undergo oxidation to give you carbon dioxide and water. It might be dimethyl peroxide or acetaldehyde or formaldehyde. All these gases will hit the inner walls of engine and piston with high pressure until the fourth stroke, creating a such kind of irritating noise. Is called as rattling noise, because of which knocking is absorbed. Okay, so in the second stroke itself, combustion occurs. That is called as explosive combustion. You might ask, what if? So what if knocking occurs? So this knocking, I think most of you might have traveled in two-wheeler, four-wheeler, anything. You get some that irritating noise as soon as you start the engine, right? That is a live example for knocking. Okay, so traveling becomes uneasy. How far you can hear that sound, right? If you go in buses, BMTC buses, you can see that sound, right? So forget about your cars because you close everything like AC, so it is less. So fuel consumption will increase, so driving becomes harder, right? And it damages the inner parts of engine and piston, thereby reducing the life of engine. So these are the effects of knocking. So how to prevent knocking? You're supposed to maintain critical compression ratio. The fuel whichever you are using, if the compression ratio of that is critical, then we can minimize knocking by using anti-knocking agents, using moderate temperature and pressure. By these, you can minimize your what knocking, or you can by using high octane rating fuel also you can minimize knocking. So what are anti-knocking agents? How to minimize the knocking? We'll discuss in our next discussion. Thank you.